functions. Has anyone seen any movies in the theater recently? Has anybody worked the gumption up to go to a theater? I'm not advocating it one way or the other. Yeah, I don't know. I don't quite feel ready to go full normal yet, for sure. Anyway, enough of that. If nobody has questions, I have a question. Where is everybody? So I'm really happy you're here. That's really good. But I've got 8 people here right now, and this is troubling. 9. All right. If I include myself, we're in the double digits, but I never include myself. Okay. If there's no questions from homework, we're just going to get right back in to where we left off. If you missed yesterday, you really want to go watch that video. We do the functions handout that's up on Canvas. We do a deeper dive into functions than the book does. The book kind of mentions it briefly, and there's 1 or 2 questions about it. But functions are a huge idea, so I did a deeper dive into functions. We're going to do, holy shit, what just happened? Everybody hold on. Okay, all right, sorry. My laptop decided to completely go dark. It's back, all right. We're going to get into this fully. So we took a minute and we talked about functions separately. So now we're going to get into these exponential forms of things. And just remind you, I said yesterday, we've talked about exponential growth before. Do you guys remember? Let me see. I think they have an example problem here. Can you tell me, now, don't look at this graph. Just pretend like this was the only thing we had. Can somebody tell me quickly, how can you tell this is not linear growth? Let's see how much we remember. How can you tell that that's not linear growth?
The line is not straight.
Don't look at the graph. Sorry, pretend like the graph is not here. All we have is the table. How do you know it's not linear growth?
Because the numbers don't go up by the same increment every time.
Good. It's not based on adding something. Now, take a minute and let's do what the number 2 is. Can somebody please, if you have a calculator near you, here, somebody do 16,050 divided by 15,000. Somebody else do 22,510.96 divided by 21,038.2. Somebody says pick a number and divide by the one before it. Go. I'll do it too. I'll pick a number and divide by the one before it. Okay. Are you guys doing it? Everybody's doing it. Picking a thing and dividing it. What do you guys get when you do that? Anybody? Oh, this is bad. Nobody, is anybody? Are you guys dividing?
Yeah. You asked to divide 2 numbers, correct?
Yes. So pick a number and divide. So pick an output, right? A value, and divide by the one before it. Just pick any of them and divide by the one before it. Okay. And as you get answers, let me know.
The first one is 1.07.
Okay. Did anyone do anything else? Did anyone do anything?
I'm trying to do the last one right now.
Okay.
Okay, you got the last one. I'll do 5 and 4 then.
Okay.
Oh my gosh. Oh, how my Texas Instruments is not working with me right now.
The machines are starting to take over.
These calculators that will last literally forever.
The rest of you guys can do something too. Are you guys out there? All you gotta
Oh, is it 1.07? Was that what you got at for the first one as well?
Jeremy, I think that's what he got. 1.07, right?
Yeah.
Ethan,
Yeah,
do you
right.
have yours?
Mine's also 1.07.
Interesting. All right. Does anyone remember if I keep multiplying by 1.07, What is the percent increase that represents? Oh, shit. You guys remember something that looks like this? Hold on. Let me get this thing going here. There we go. Does that look familiar to anybody? Does that look familiar?
Yes, that looks familiar.
I was going to say, you could say no. and you wouldn't feel bad. If you're being honest, then don't feel bad about it. But we did talk about this. Now I made you feel bad if this doesn't look familiar. So what does R represent? Does somebody remember what R represented?
The rate?
Yeah, the interest rate. This, if we look at this like money we put in the bank. So P would be the principal, the amount we put in the bank. R is the interest rate. T is the time in years, and A would be the amount in the account. So this actually works for any situation where I have something growing exponentially. So what we just figured out, since this divided by this is 1.07 and this divided by this is 1.07 and whatever, then we just figured out that the rate must be 0.07, 7%. It is growing by 7% each year. Now, let me see if I could push this a little bit. What do you think I would have gotten here if it was actually shrinking by 7% each year? If it was actually decreasing by 7% instead of increasing by 7%? What do you guys think I would have gotten instead of 1.07? Ba-bum, ba-bum, ba-da-ba-bum, bum. Anybody? So I really want this to make all the sense of the world. If it doesn't change when I multiply it by 1, if a number doesn't change when I just multiply it by 1, is that cool, everybody?
Sure.
I love it. If I multiply by 1, it's not going to change. So if it doesn't change, I could say I multiplied it by 1. Good job. So if I saw a table where it was 2, 2, 2, 2, 2, I'm like, okay, I just keep multiplying by 1. If I increase it by 7%, I multiply it by 1.07. It picks up an extra 0.07 each step. It goes up by 7%. So what if it actually went down by 7%?
Would it be 0.93?
0.93. Shit, yes. So if it was a 7% decrease, I would just multiply it by 0.93 each time. That would be something like radioactive decay or something like that. Okay. Maybe. Okay. Oh shit, what's happening? Chat. Been trying to oh, okay. You're okay. All right, hold on. Let me see. Clear all this away. What is your blah 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 blah? Who cares? We already did this, blah blah blah. Oh, now I want to create no, we already all right. Starting with 15,000. So we've already got this put together. I kind of reminded you guys what this is going to look like. Oh, let's see. So if I start at 15,000 and I want to know how much I'm going to have in there after 10 years. So I'm not going to multiply it by 1.07. I'm not going to write this 10 times. Right? I'm not going to multiply by 1.07 10 times. What am I going to do? Of course, I'm not going to write this 10 times. What's the same thing as multiplying by something 10 times? I can multiply that thing. How do I say this? What's another way to write 2 times 2 times 2 times 2 times 2 times 2? Don't tell me the answer. Just tell me a different way to write it.
Exponent.
Sure. So 2 to the
5th.
5th. I like it. You guys with me? So what would I do instead of writing 1.07 10 times? I would say 1.07 to the 10th power. So that would tell me how much is in there after 10 years if it keeps growing by 7%. So what would I put here instead of 10 if I didn't know how many years I wanted to let go by?
You would put an X.
Yeah. So however many years I want to let go by, that's where I would put it right there. So that X marks the spot of where I'm going to put the number of years. Another way to write this, it's just a slightly different way to write this. You ready? What form have I used there? It's the same thing. It's just a little more explanatory. What form is this in? What is this? You could do it. Remember we were doing this yesterday?
It's a function.
Function notation, function notation. Bye-bye. Coolness. All right, you guys okay out there? No?
Yep.
Yeah, okay.
Yeah, I'm just trying to make sense of it all. Well, I'm there though.
Okay, okay. Let's see. Let me clear this away. Okay. Blah, 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 who cares? All right. Oh, somebody tell me, look at this equation. Can somebody tell me what is the initial amount? What amount does it start with? If this is the equation.
12,500.
Yeah, 12,500. Now somebody else tells me, somebody else tells me, what's the interest rate? How much is it growing each year?
5%.
5%. Kick ass. Bam, bam, easy. All right, I like it. Let's see if you guys remember how to do this in your calculator. Can you all please, don't say anything out loud yet. Can you please figure out how much is going to be after 11 years? If it's kept in there for 11 years, here, I'll do it too. Because I'm not going to do that in my head. That will hurt my brains. Hurt my brains. So if I used, you don't have to do this, don't worry. But if I did write it in function notation way, I could do A of 11 years. So this is really just, can you throw this in your calculator correctly kind of question, right? Because you put 11 here in place of X. All right, now tell me, what'd you guys, anybody get something?
Would it be 21,379.24?
Yeah, don't forget her 24 cents, exactly. Kabam.
4 cents. Awesome. Cool.
I like it. All right, don't worry about Excel. We can't use Excel. We don't have enough access to Excel. Okay, please let me know if you're not able to get that number. All right, I'm going to clear this away. Clear. All right, so here's where they talk about functions. So maybe you can tell why I did a whole handout, because they really don't talk about it much. Blah, blah, blah. They finally catch up with what I was talking about. Who cares? All right, that's enough of that. Let's go to this section. Now look at this bad boy. This is obvious. Now this is neat. So this is really interesting. I can't remember. I think I looked this up. I can't remember. There is an accepted like average decay rate for caffeine in the system. So all of my coffee drinkers out there, you get an injection of caffeine and then it slowly leaves your system. Okay. So this is a beautiful example of exponential decays. Can somebody do exactly what we did before? Take a number and divide by the one before it. Somebody else take a different number, divide by the one before it. Let's figure this thing out. Shit. I'm going to do several just to be sure. All right, let's see what you guys get. Does everybody understand what they're doing? Take a number, divide by the one before it. Somebody else, take a different number, divide by the one before it. All right. Has anybody got a number yet?
0.8.
Okay, somebody got 0.8? I don't know. Anybody else get a different
I also got 0.8.
0.8? Okay. Anybody else play along? 0.8, okay. Okay. I got 0.798 for one of them, and we'll just call that 0.8 because we're all humans.
Yeah, 0.8.
All right.
For one of them, I also got 0.80054.
Good. I like it. So did I. Wouldn't they? Don't they all basically come out to be 0.8? Why aren't they all perfectly 0.8? Do you really think that all of these just stopped here at one decimal? Or do they maybe round?
They probably rounded.
Hell yeah. And that's why not all of these come out to be perfectly 0.8. Can somebody tell me what percentage does it actually decrease by? When we got 1.07, it increased by 7%.
2%?
Say again?
2%?
No, careful, not 2%. That would be 0.02,
Oh, 20%.
20%. So remember when we got 1.07, wasn't that 7% growth? Because it's 1 plus 0.07. So 0.8 is 1 minus 0.2. So it's 20% decrease. So over time, it's 20% per hour that it decreases by. So is everybody with me? Does that make sense why it's a steeper drop at the beginning and then it's a smaller drop as it goes on? Does that make sense? Because at the beginning, 20% of this is big, but 20% of this is smaller. And then way down here, 20% of this is tiny. Tiny. So that's why it's got that shape. Starts off with a steep slope down, and then it kind of becomes more gentle as you go on because there's less shit to take a percentage of. So you're going to decrease by less. Is that?
Yeah, I get it.
Okay.
That makes sense.
All right. Let me clear all this away. What are they trying to tell me here? Let's see. If you're the coffee drinker, how much caffeine was initially in your system? Okay, that's easy. How much caffeine is initially in the system of this person?
180 milligrams.
180. I like it. So after no hours, there's 180 milligrams of caffeine. All right, let's see what else they ask here. Oh, who cares? We already did all this. This is what I asked you to do. Remember, when divide the two and you got 0.8, divide the two, you got 0.88. Oh, blah, blah. All right. Who cares? Who cares? Who cares? Blah, blah, blah. Describe what exponential k looks like compared to. All right. So obviously, what's the main difference between this graph and where's the other graph? There's this graph.
One's going up, the other one's going
I like what's going up, the other one's going down. In fact, this one looks just like the other one if I read it this way. Right? I like it. So it's kind of like what we call a reflection. One is a reflection of the other one. Okay, let me see. Do they say anything else interesting? Blah, blah, blah. They finally catch up to us. Write a function. Okay, here we go. Here we go. Let's write what we know. I know it starts at 180. I know that the one leads to 8.8 of the one before it, right? Or I could even say it decreases by 20%. So it's going to have the exact same form, really, where P is kind of weird now. It's going to have the same exact form. So the amount of caffeine in the system is equal to the original amount. But what's this going to be now? Does it increase or decrease by how much?
Decreases by 20%.
So minus 0.2, and that of course is where the 0.8 comes from. So that is the equation right there. So can you very quickly tell me, and let me, I should be smarter about this, Jeff. Let's reinforce function notation, Jeff. Are you the teacher? I think I am. All right. So what about after 4 hours? How much caffeine, how many milligrams of caffeine are in the system?
$73.7.
Yeah, 73.7. Let's say 728, right? Milligrams. Right. Is that cool, everybody? Can you guys all do that? All right, so let me go up here. I can pull my work up here. Let's check it out. What's the chart say after 4 hours? Dude, all right. You know, it's kind of like, well, yeah, Jeff, we made this formula based on what we saw. So of course the formula is going to give me what we saw. Of course it is, right? But that's kind of a nice check to make sure you got the equation put together, right? It does give me the right number there. Always nice. Always nice. All right, let me clear this away. Let's see what other weird shit they talk about. Blah, blah, blah. Oh, look at the graph. How long until there's 40 milligrams? How long until there's 40 milligrams left in the system?
Somewhere between 5 and 6 hours.
No?
Oh, 6 and 7 hours.
There you go. So if you look at, here's 40 milligrams, right? So how long until there's 40 milligrams? Here, roughly. So a little more than 6.5 hours. Do you guys see that? We did a problem just like that on the worksheet yesterday, where we had it. I gave you a graph and we had to kind of see where was something happening. All right, same idea. If they give me the graph, that kicks ass. They've already done all the work for me. All right, let me clear this away. Oh,
I have a question
yes.
with that one.
Yes.
So like let's say we're answering a question just like that. You just want us to write somewhere between 6 and 7.
Yeah. Let me see exactly how they word this thing again. Here we go. Use the graph to estimate the amount of time. So you could say somewhere between 6 and 7 hours. That would be fine. You could say about 6.5 hours. That would be fine. Either one, because we're just estimating. So it doesn't have to be
Okay, there you go.
perfect number. Yeah. Blah, blah, blah. Who cares? All right. Who cares? All right. Oh, all right. This is interesting. Can you think, I like this kind of problem. Can you think of a situation that this would describe in real life, that this would actually model in real life? I mean, you can come up with a very boring one, right? You could say,
Walking up a mountain.
okay, so your elevation per minute or something as you walk up a mountain. So it's getting steeper and steeper and steeper. See that? Exactly. I love it. And that all depends on the shape of the mountain, right? But yeah, that'll still work. All right, what about this guy?
A depressing drone.
All right, let me think about that. Wait a minute. A depressing drone. I don't know what that means.
Like malfunction.
Oh,
Drone
malfunction.
malfunction. It just goes up and it just goes whee. Down it goes.
I like that. Wee, woo, wee. All right. So this is kind of doing this over time here. So you could be very boring and say the amount of caffeine in your system, Jeff. Yeah, I just came up with that. Right.
A bad investment.
Yes, a bad investment. Sure, you should have gotten out here, but you waited, and now you're like, well, damn. Okay, all right. How about a plane landing? Right, they kind of come down swiftly, but as they get closer, they want to slow their descent so that, you know, don't smack into the ground. It's normally, I think it's a bad idea. It's frowned upon to smack into the ground with a bunch of passengers on board. Okay, let me see. Blah 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 blah. All right, now look at this beautiful thing. Oh my goodness, it looks like Christmas lights or something. I can't think about what it looks like. Something in the sea, like some kind of weird seaweed kind of stuff. This one is neat. I like this problem. There's multiple things happening. What is this? Is this teal? This top color? It's some kind of weird green blue. I don't know if it's teal. I don't know what that is. What does that represent? Anybody? That this graph right here, what does it represent? This top graph?
Salary.
Salary. I like it. And then of course this like Dijon color here is expenses. And this purple is investments. Right? So this is specifically about this dude, Joe. This isn't like normal, whatever years old. This is what Joe did in his life. So I'm going to ask you questions to interpret the graph. So there's not going to be a lot of mathematical work. It's going to be just interpreting stuff from the graph. They do eventually get into some math, I think. Yeah. Wait a minute. Where? Here we go. Yeah, some math. Ooh, dude. But most of this is all about, wait, is this yeah, okay. Blah, blah. This one's kind of a long one. Look at this. And it keeps going. Here's more about Joe. I know this is Fran now. Sorry, we got Fran. Anyway, so that's going to be exciting. So you need to get into that homework and try it out as soon as you can. Okay. Oh, let me look at one thing. Hold on. Do I have, oh, let me see where. No, I don't think so. Okay. Give me a second. Doobie doobie doo. Doobie doobie. Doobie doobie doo. That's right. Okay. I just want to make sure. This is not, what, let me just show you this. All right. So here's what we do in this section, 1, 2, 3. We skip 4, we go to 5, and we skip 6. Let me just show you real quick what 6 is about. 6 goes deeper into too much. I felt, yeah, this is something we don't even do in statistics right here. So it's all about kind of like gathering data, fitting data to an exponential curve. So this went a little beyond what we even do in statistics. So that's why I'm not doing section 4.6. So I'm really sorry if you love golf and you love exponential equations and you're like, I want to see how those two things go together, Jeff. Well, it's too bad you took the wrong teacher. But I want to talk about, oh God, I want to talk about irate ducks. That sounds like somebody telling me what they do for a living. That duck is about a 7. So we're going to get into now, obviously, has anybody ever played Angry Birds, which is obviously what they're kind of playing on here? Have you guys ever heard of
Yes.
Angry Birds? Yes.
Long time ago.
Long
Yeah.
time ago. Yes. And you're like, are they still out there? Yeah, they're still out there doing stuff. I don't know. I played Angry Birds for a while, and then there was a Star Wars version of it where the birds had little lightsabers and stuff.
I played that one too.
Yeah, I did too. And then I'm like, okay, I'm done with that. That's enough. I get the idea. But obviously, when you pull back, so if you have never played Angry Birds, you put a little bird in a what do you call it, catapult kind of thing? What do you call it, slingshot kind of thing? You have to pull it back, and you can change the angle. So depending on the angle, if you put it like straight up, it would, of course, the bird would go wee, pop. So you want to do it at the right angle, so to go over and knock down structures that these evil pigs, right? So it's Angry Birds and evil pigs, the age-old battle between Angry Birds and evil pigs. So this section's all about parabolic motion. So I think this has come up a couple times. What a parabola looks like a U shape, right? So we're going to get into quadratic equations When I say the word quadratic, does anyone have anything come to mind? No, that's surprising. Quadratic. No, no quadratic. Quadratic formula. Does that sound familiar to anybody? Let me, negative b plus or minus square root of b squared minus 4ac divided by 2a.
Yep.
All right. So a few of you guys. All right. That actually, I don't think is a part of this. I want to let you know what is coming. I did this earlier with somebody in office hours. What we're approaching is, where are you? So we do some more algebra stuff. What we're approaching slowly but surely is the F word. Does anyone know what the F word is in mathematics? Be careful what you say, you're being recorded. Did I do this? I keep forgetting to do this. I'm really sorry. Jeez, I didn't spotlight myself. So you guys are going to show up in this video again if you talk. F
Is
word?
it the function?
No, it's this one.
Factor.
Factoring, right? All right. So let's go back. Sorry, I just want to do a little quick looking forward with you guys since we just finished the section here. Where am I at? Here I am. Okay, we just finished this section here. I want to talk a little bit about 4-6, not 4-6. Sorry, that's one we don't do. 4-7. Okay, there we go. Angry ducks. Let me think. Yeah, so here's a good picture of it. So depending on the angle you put this at, so if you put it like this, then the duck might do this, pop. But if you put it at the angle it's at, then it might do something like this, and then it would knock this down. And what are these things supposed to be? They don't use pigs. They obviously are being very careful to not. Oh, beavers. Okay, so ducks and beavers versus birds and pigs. Okay, I got you. Yeah. Oh, let me do this. All right, I'll do this. This is interesting. I haven't shown you. No, I'm pretty sure I didn't show you this. Have I shown you the video about playing darts?
I don't think you have.
No. So, let's close on. Oh, geez. So stay with me. We're gonna watch this. I'm gonna have to stop recording because it's gonna like copyright business. Hold on a minute. Hold on a minute. Dartboard. All right. I don't know. Let's see if I can find this real quick. Here it is. All right. Sweet. Look at me finding shit. All right. Ad. Let me let this ad play. Hold on. So what I'm going to show you is really, really cool. Anybody ever play darts? Anybody ever? Do you know darts? Anybody ever played darts? No.
No, it sounds like fun though.
All right. So you all know what it is, right? You got a dart board.
Yeah.
And you try to throw the dart and hit the board. And depending on the kind of game you're playing, you could play for points. I've watched like a few minutes of like professional darts, and I'm like, oh my God. Normally I'm just like, oh, I hit the board. Oh my God, I didn't hit somebody in the head. Yay, it's a victory. So normally when I've ever played darts, I was slightly inebriated and people needed to stand away. Same thing with the people I was with. So darts can be very dangerous. All right. So this is a cool thing. And now all right. I'm just going to show you this video. I'm going to stop recording. Let me kind of speed it up a little bit. Just please watch this video. It's really pretty cool. I'm not endorsing this person. I'm not any of that. I just love the math. There's some math in there.